Happy day students. Today I am going to share with you the topic of Internet of Things. So, the focus of the key areas in Internet of Things are its definition, its characteristics, what are the blocks that make up the IoT devices, its physical design, logical design, and how it's embedded or other technologies have been used into IoT, difference between IoT and machine to machine, domain specific IoTs, and at last the tools that are used for Internet of Things. So, moving on to the actual definition of Internet of Things, this was coined in 1999 by the scientist Kevin Ashton. So, the Internet of Things refers to the network of physical devices, vehicles, appliances and other objects that are embedded with sensors, softwares, network connectivity, which all will enable to collect the information as well as to exchange the data. So, to know more about this, we should actually know the difference between Internet and Internet of Things. So, we know the regular Internet where we access the information, and in Internet all the computer systems, mobile phones have been connected where each one has been given an ID. Now, the technology has advanced and we are making the objects or human, not human beings, any of the appliances, we are making all these objects to talk to each other and to help for the betterment of the world. So, that is the concept of Internet of Things. Moving on to its characteristics. These Internet of Things has an features of dynamic and self-adapting. That means, we know the Internet of Things are smartphones or sensor based appliances which we see in our day-to-day life or which we will use in our day-to-day lives in TVs, smart lights or smart roads, etc. So, in all these appliances, the dynamic and self-adapting nature is there. All these devices are very dynamic and they are adaptable. That means, they can change their modes according to the operating conditions. Example is the surveillance camera on roads where they are capable of changing over the modes according to the day and night fashion. Second is the self-configuring. So, without much human interventions, these IoT devices are capable of upgrading their softwares or setting up the network infrastructure. Moving on to the third feature, interoperable communication protocols. We know in a networking language, protocol is the language used between the communication devices. So, these communication protocols, in IoT devices, many different protocols have been supported. So, it supports major all advanced protocols. Then moving on to the fourth feature, unique identity. All the IoT devices have given a unique identifier. Identifier is an address that was given such that the machine is capable of receiving and sending the information. Last one is the integration to the information network where it supports all the networking interfaces. Moving on to the building blocks. What is about an IoT device? What it consists of or what are the functional components of it? So, if you see that it is mainly for the connectivity, it is an object has to be connected, then only it has to be, then only we can send or receive the information. So, for the connectivity you need an internet connection or the USB ports, etc. And for processor we know that it is a CPU and it consists of all other parts like interfaces. Interfaces are actually the input output parts of the IoT devices where the input is the sensor or the actuators where they can recognize the signals that are being generated by the physical devices. And moving on to the device information part can be either audio or the video information, and you need storage space as well as the memory parts along with the graphics. So, these all make up an IoT device to talk to an object. And moving on to the physical and logical design. So, we know physical devices are the actual raw parts where the IoT devices can talk to the objects, and logical is the communication part. So, moving on to the physical design, we know in any networking infrastructure or networking structure there are protocols TCP IP, we know those protocols are very familiar, right. In the same way, for IoT devices to work, we need a network architecture. It consists of 4 layers like link layer, network layer, transport layer and application layer. Moving on to the first one, the link layer, where the actual physical transmission of data takes place. So, the protocols that are used under the link layer are based on the Ethernet IEEE standard 802.3 Ethernet, 802.11 Wi-Fi and 802.16 WiMAX, 802.15.4 low power ranged wide personal area networks. Okay. So, these are the protocols where their difference lies in the rates of data transfer, how the transmission to actual physical devices takes place. Moving on to the second one, network layer, we all know that in order to communicate over through the cables, coaxial cables or wireless cables, whatever it might be, we need an address bit. So, this IPv4 and V6 stands for the internet address, internet protocol address version 4 and version 6. The difference between these two is one is some 64 bit, other one is some 128 bit. So, according to this the network layer is responsible for sending the datagrams over the source and the destination areas. Moving on to the transport part, this contains the actual content. The message part is being delivered using this transport layer. So, we come across two protocols that are used under this transport layer. One is the TCP IP protocol, that is TCP protocol, transmission control protocol, other one is user datagram protocol. One is connection oriented, the other one is the connectionless protocol. So, these two protocols helps us to actually send the information from source to the destination. The message content is taken care by this particular link area. And then last one is the application layer, where application layer actually gives the user interface from source to destination. So, through all these protocol layers, the content, the IoT device can send and receive the information. So, in the application layer, these are the various protocols, HTTP protocol, coaxial. So, these are the various application layer protocols. One is the WebSockets, DDS, data distribution service, and you have AMQP protocol. So, all these protocols, we know that an application layer mainly takes place with the browser communication. Whenever user sends some request to the server and it is responded by the server, so the protocols like HTTP, FTP, these all comes into place where the information will be delivered to the user interface. Okay. So, moving on to the logical design, these are all the basic blocks of an IoT device, where we have a device, a management part, services, communication, security and application. So, all these are the basic blocks of an IoT device. So, if you see actually what are the services an IoT device can give, mainly IoT devices can provide you the monitoring part, that means you can get the status of any device at any time, and you can control the device by being in a remote position. So, these are all the various services an IoT system can provide us. So, we know that communication can be in either of the ways, either you receive the communication or you send the communication depending upon your application. Okay. And management is total infrastructure maintenance of that particular device remotely through the sensors, through the networking channels, okay, and through the IO parts. And security, which is very, very important, because any device that is there without man intervention or human intervention needs to be secured properly, so that it is available 24/7. So, these are the various functional blocks of an IoT device. Then moving on to its logical design part, how it is going to communicate with other devices. So, the communication takes place in three parts or three models. We call it as a request response model, publish subscribe model, or push pull communication model. So, in all these models, what the actual taking place is from the source to the destination, or communication between two IoT devices, or communication between a machine and an IoT device, or an object and an IoT device, forms under this category. Whether a client will make a request, server searches for the information and fulfills the request in the first model. In the second model, publish subscribe model, the information, the messages are sent to the subscribers. So, subscribers, they pull out their information, and through a middle agent called the broker, it will be dispatched to the subsequent consumers. In the third model, push and pull communication model, all the information have been sent to the queue. So, from the queues, the consumer collect the information. So, this is about the third way of communicating with respect to the IoT devices. Then moving on to the IoT enabling technologies. So, enabling technologies, these are the technologies that are advanced and makes the IoT happen to the real world. So, what are the major technologies that are used in handy with the IoT devices are, the first one, the wireless sensor networks. second one cloud computing, third one big data analytics, communication protocol and embedded systems. So, moving on to the first one, these wireless sensor networks are distributed devices where they have so many sensors to monitor the environmental and physical conditions. So, mainly if you are taking an IoT device of a for a healthcare product, you will have your wristband watches, or when you take a weather monitoring system, you will have the sensors placed at different road networks, or when you are having any surveillance camera, you will be placing on any street lights. So, these are the ways where it senses the environmental as well as the physical conditions. Then second was the cloud. We all know that cloud is a place where we can get infrastructure as a service, platform as a service and service as a service. So, three SaaS, IaaS and PaaS are the three ways of cloud delivery, where the software itself will be given as in a pay model for you. Then moving on to the next one, big data analytics. It is a method of studying the massive information or huge amount of data. You want to draw conclusions or you want to arrive at patterns. So, this big data analytics come into picture. So, why we are saying that IoT devices embeds with this big data analytics? Because each of the sensors, each of the IoT devices generates so much of information per second. So, those informations has to be stored onto the cloud, because information is real time. You need a server to store the information and to access that information, and this big data analytics always deal with enormous amount of information. Then coming to the communication protocol, this we already discussed this. A protocol is a language for the devices. Okay. So, using those communication protocols, there are umpty number of protocols that are being supported by these IoT devices. Last one is the embedded systems, where it is a combination of both hardware and software to do all our tasks. So, the good examples of these are the microcontrollers, microprocessors, networking units and the memory unit. So, moving on to, is there any difference between IoT and M2M? What is this M2M? Why it is intermingling with IoT? So, here comes the major two differences between these two, and IoT gives an intelligence, but machine to machine it is only a mere intelligence is given. And the last major difference is the internet connectivity is essential for IoT devices to perform, where in M2M you have without internet also the machines can talk to each other. And mainly the major thing is here you are interfacing an object with a machine, here a machine to a machine, everything is a connection point to point here, and here through networking it takes place. So, in this way we can differentiate an IoT with an M2M device. And moving on to the major application part of an IoT, where in real world much exploration and research is going on nowadays. So, the major applications are in home, cities, environment, retail, logistics and healthcare. These are the different applications where we are using different sensors to improve our standard or way of living. So, at home we are using smart lighting, where when we enter the room it senses and the lights are on, or the fans or any smart appliances like how the TV when we enter, and depending upon our mood swings also the channel can be changed. Okay. And about the smoke detectors, suppose our house or home is in a fire, the detectors will smell the smoke and it will take the necessary action. So, these are the different appliances with respect to the home. Moving on to the city wise, you have your smart roads or the surveillance camera, where IoT devices are sensing the objects or sensing what is happening on roads and taking appropriate action according to it. Moving on to the environment, we all know the weather forecasting or for forest fire detection or river flood detection or weather monitoring, all these comes under the environment. Moving on to the retail, we are very well known of the smart payments or the vending machines. Without humans, nowadays we are getting the products, desired products through the vending machines. And when you move on to the logistics, it is about the ship monitoring or routing scheduling. These are the various applications where the devices are in place. And health, we all know that all the wristband watches, smart watches we are wearing nowadays are capable of measuring the sugar levels, blood pressure levels, and we are using it as a wearable electronics. So, these are the various domains where we are using the IoT devices. And moving on to the last concept called the tools that are used to make this happen, the IoT devices talk to each other, is the famous Raspberry Pi and the Arduino. So, these are the boards where it is a small chip where these chips are affordable, and this chips is capable of communicating with all the other functional parts. So, they can talk to a sensor, they can talk to a computer or a networking unit or a memory unit. So, because of this Raspberry Pi and Arduino, this IoT devices are in place. And moving on to the actual difference between these two are helpful for the communication between the other devices. The main difference, it's a microcontroller and it's a microprocessor. It's a 8-bit architecture and it's a 16-bit architecture in case of a CPU. So, cost wise if you see, Arduino is cheaper, Raspberry is expensive, and with all the languages, Python, data analytics language comes handy with both the controllers, whereby we can do very much programming and make all the objects around us talk to each other. So, at the end, I wish to conclude this session saying that in spite of having internet of everything, everyone, anywhere, anytime, they must augment the human intelligence and uphold the human sustainability. Thank you.